So we are going to solve today Addition Mathematics Paper 2 Specimen Paper for examination from 2025. It's 2 hours paper and the total marks for this paper are 80. Let's solve question number 1. Okay, we have equation 5 absolute of 5x minus 7 minus 1 is equal to 14. So first of all, we will take minus 1 on other side. So it will become 14 plus 1. Then we have 5x minus 7 is equal to 15 divided by 5. So we have here 5x minus 7 is equal to 3. And then we will take one time with positive 3 and another time with negative 3 as we have absolute sign. So we have here 5x is equal to 3 plus 7 and x is equal to 10 divided by 5. So we have x is equal to 2. And here we have 5x is equal to minus 3 plus 7 will be 4. So x is equal to 4 upon 5. Now we are solving part B, which says the diagram shows the graph of y is equal to f of x. This is the graph of y is equal to f of x, which is a cubic graph. And the equation for the graph is 2 into x plus 1 whole square into x minus 1. And we have to use the graph to solve the inequality f of x is less than or equal to minus 1. So we have to draw a line where there is f of x is minus 1. So f of x is minus 1 at this point. So we will draw a line at this on this so that we can easily find out the values of x. So if we see, we have to consider the lesser part of this curve. So it means that we have to consider this part of the curve. This part as well as this part of the curve. So then we have to tell the values of x on this part of the curve. So if we'll see, if we'll join this with x-axis, it is at minus 1.45. So we have the values of x for this part of the curve as x is less than or equal to minus 1.45. And now we will consider this part of the curve. We will see this is at x is equal to minus 0.4 and this point is at x is equal to 0.85. And these are the values which are in between these two values. So we can write the range as x is greater than or equal to minus 0.4 and less than or equal to 0.85. Now question number 2. Question number 2 says for variables x and y, plotting ln y against ln x gives a straight line passing through the points 6, 5 and 8, 9. Show that y is equal to e power p and x power q, where p and q are integers to be fine. So first of all, they are saying plotting ln y against ln x means that on x-axis it is ln x, on y-axis it is ln y. And the points are 6, 5. There are 2 points. There are 2 points. One of the point is 6, 5. Another point is 8, 9. So first of all, we will find out the gradient and y-intercept using these 2 points. So 6, 5 and 8, 9. For gradient, we have m is equal to 9 minus 5 upon 8 minus 6. So which is equal to 4 upon 2, which is equal to 2. Then we have to find out the value of c. we have here y is equal to mx plus c. So y is, you can take any of the coordinates from these two. So we are taking this one here. 5 is equal to 2 into 6 and plus c. So we have here 5 is equal to 12 plus c, and c is equal to 5 minus 12, which is minus 7. If we substitute in linear equation, then we have here y is equal to 2x minus 7. Now, we know that ln y is plotted against ln x. So in place of y, we have ln y, and in place of x, we have ln x. So we'll substitute here ln x and ln y. Okay, now we have ln y is equal to ln x square. We can make this the power of this x minus 7. We'll simplify it. Ln y minus ln x square is equal to minus 7. Now we can write this as single logarithm ln y upon x square, as there is minus sign, is equal to minus 7. So now we can write it as y upon x square is equal to, this minus 7 will become the power of the base of this log. So here ln means the base is e. So we can write here e power minus 7. So now we'll multiply this by this. So we will have y is equal to e power minus 7 and x power 2. So we'll compare it with y is equal to e power p x power q. So the value of p is minus 7 and the value of q is 2. The next question is related to quadratics. It says find the values of the constant k for which the equation 2k minus 1 x squared plus 6x plus k plus 1 is equal to 0 has real roots. Whenever in the question it's given about roots and we have to find out the value of any constant, given that the equation is a quadratic equation, we can use b square minus 4ac. And here, when the roots are real roots, then we can use b square minus 4ac is greater than or equal to 0. Right? So we will take the values of a, b, and c. A is the coefficient of x squared, which is 2k minus 1. B is the coefficient of x, which is 6 in this case. And c is the constant term, which is k plus 1. So now we will substitute these values in b square minus 4ac. We have here 6 whole square minus 4 into 2k minus 1 into k plus 1 greater than or equal to 0. So we have 36 minus 4 into 2k square plus 2k minus k minus 1 is greater than or equal to 0. We'll do the expansion of these two brackets. Now we will multiply this minus 4 with all of these terms. Or first we can simplify it. 2k square plus k minus 1 is greater than or equal to 0. Now we have here 36 minus 8k square. We are multiplying minus 4 by the bracket. Minus 4k plus 4 is greater than or equal to 0. Now we have minus 8k square minus 4k. 36 plus 4 is plus 40 is greater than or equal to 0. To simplify the equation, we can take here minus 4 as common. So when we will take minus 4 as common, it will be 2k square plus k minus 10 is greater than or equal to 0. So now this minus 4 will be divided on that side. So whenever we divide by negative number, then the sign of inequality is to be changed. So it will become less than or equal to 0. You can do middle term breaking. 2k square plus 5k minus 4k minus 10 is lesser than or equal to 0. 2 10 is a 20, and we have to make the factors of 20 in such a way that we get plus k. So 5, 4 is a 20, and 5 and 4 are the factors which gives the answer as 1k. So now k is common. We'll be left with 2k plus 5 minus 2 is common. 2k plus 5 lesser than or equal to 0. So now we have here k minus 2 and 2k plus 5 is less than or equal to 0. Now we'll take out critical values by creating k minus 2 to 0 and 2k plus 5 to 0. So we have here k is equal to 2 and k is equal to minus 5 upon 2. If we sketch the curve for this as it is quadratic, so we have one of the point here at 2 and another one here minus 2.5, and if we see this one, the coefficient of k square is positive, so the graph is to be like this, and we have to consider lesser part of the curve. So this is the lesser part of the curve. So here we have minus 2.5 and here we have 2. So we can write the values of k as greater than or equal to minus 2.5 and less than or equal to 2. Here we have minus 2.5 and here we have 2. So the values of k are from minus 2 to 2. Let's move on to the next question. A photographer takes 12 different photographs. There are 3 photographs of sunsets, 4 of oceans, and 5 of mountains. The photographs are all arranged in a line on a wall. Find the number of possible arrangements if the first photograph is of a sunset and the last photograph is of an ocean. So there are 3 possibilities at first place, and total there are 1244 photographs which needs to be arranged. So we will have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first photograph is of a sunset, and there are 3 photographs of sunset. So there are 3 possibilities over here. And the last photograph is of an ocean. So we have 4 possibilities over here, right? So out of 12 photographs, one of the photograph is to be kept over here and another one here. The remaining photographs are 10. So we have possibility of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it means that we have here 3 possibilities. And if it is 10, 9, 8, 7 till 1, so it is 10 factorial multiplied by, here we have 4 possibilities, so multiplied by 4. So the answer is 4, 3, 5, 4, 5, 6, 0, 0. In the next part, they are saying, find the number of possible arrangements if all the photographs of mountains are next to each other. So there are 5 photographs of mountain which are next to each other. So if we keep those 5 in the box, 1, 2, 3, So these are 5 photographs of mountain. These can be arranged in 5 factorial ways. And the remaining are 3 photographs of sunsets and 4 of ocean. So we have total 7 photographs remaining. So we have 5 factorial here and 7 factorial for these 7 photographs. And these mountain photographs can be kept at this place 1, 2, 3, 4, 5, 6, 7, and 8. 8 places these mountain photographs can be kept. So we will multiply 5 factorial by 8 by 7 factorial. So the answer is 4, 8, 3, 8, 4, 0, 0. Now we have 3 of the photographs are selected for a competition. Find the number of possible selections if no photograph of a sunset is chosen. So it means that 3 photographs to be selected from 9 photographs, because no photograph of a sunset is to be chosen. So from 12, we have to subtract 3 photographs of sunset. So remaining are 9. Out of 9, we have to select 3. So 9C3 is 84. Now, the next is find the number of different possible selections if one photograph of each type, sunset, ocean, mountain, is chosen. So one photograph from each category is to be chosen. So 3C1 into 4C1 and into 5C1. So when we multiply these 3, we will get 60. So now we are going to do question number 5. Given that y is equal to 10x, use calculus to find the approximate change in y as x increases from minus pi upon 4 to h minus pi upon 4, where h is small. So first of all, we can find out change in x, delta x, which is equal to h minus pi upon 4 minus pi upon 4. So we have h minus pi upon 4 plus pi upon 4. So this and this would be cancelled out. So delta x is equal to h. Now we have to find out dy upon dx. And then finally, we have to find out approximate change in y, which is delta y. So for dy upon dx, we will differentiate this. When we differentiate 10x, we get sec square x. So we can substitute the value of x as minus pi upon 4. So we have here sec square minus pi upon 4, which is equal to 1 upon cos square pi upon 4. The value of 1 upon cos square pi upon 4 is 1 upon 2. So 1 divided by 1 upon 2 is equal to 2. So now dy upon dx is equal to delta y upon delta x. So we have dy upon dx is equal to 2, and delta y, which we have to take out, and delta x is h. So delta y is equal to 2h. Now, question number 6, which says a curve has equation y is equal to ln 5 minus 3x, where x is less than 5 upon 3. The normal to the curve at the point where x is equal to minus 5 cuts the x-axis at the point P. Find the equation of the normal and the x coordinate of P. So we have to find out the equation of the normal. So first of all, we will find out dy upon dx, which will help us to find out the gradient for normal. So when we will differentiate this, it will be 1 upon 5 minus 3x. And then the differential of this, which is minus 3. So we have here minus 3 upon 5 minus 3x. So now we will substitute here the value of x as minus 5 because we have to find out the normal to the curve at point where x is equal to minus 5. So minus 3 upon 5 minus 3 into minus 5. So it is minus 3 upon 3 5s are 15 and it will be 20. So minus 3 upon 20 is the gradient of the tangent. So gradient for normal is negative reciprocal of it. So it will be 20 upon 3. Now we have got the gradient for normal. Now we have the value of x as minus 5. We have to find out the value of y so that we can make the equation. For y, we will substitute the value of x in this equation, which is minus 5. So we have y is equal to 5 plus 15 would be 20. So it is ln 20. So now we have here gradient of normal as 20 upon 3 and the coordinates are minus 5 comma ln 20. So we'll make the equation y minus ln 20 is equal to 20 upon 3 x minus 5 will become x plus 5. So we have here y is equal to, we will multiply this by this and we will take minus ln 20 on this side. So it will be 20 upon 3x plus 20 upon 3 multiplied by 5 is 100 upon 3 plus ln minus ln 20 on this side will become ln 20. So we have here y is equal to 20 upon 3x plus ln 20 plus 100 upon 3. This is the equation for normal. Now we have to find out the coordinate, the x coordinate of P, and P is the point where the normal curves the x-axis. It means that the coordinates are x comma 0. It means that we have to take the value of y as 0. So we will take y is equal to 0, 20 upon 3x plus ln 20 plus 100 upon 3. We have to take out value of x, so we can take these two on other side. So we will have 20 upon 3x is equal to minus ln 20 and plus 100 upon 3, and x is equal to minus ln 20 plus 100 upon 3, and we will multiply this by 20 upon 3. By using the calculator, we will get the value of x as minus 5.4.